A ball of mass 200 grams is thrown vertically downwards with a velocity of 10 meters per second from a cliff of 13 meters above the ground. When ball A hits the ground, it is in contact with the ground for 0.3 seconds and it then bounces back with a velocity of 24 meters per second until it reaches a maximum height of 30 meters after the first bounce. See the diagram below, ignore the effects of air friction. So 3.1, you define the term projectile. So projectile is the object that is moving under the influence of gravitational force. So we can try to define it, no problem. This is 3.1. So projectile is the object moving under the influence of gravitational force. So this is the object moving under the influence of gravitational force only. So don't confuse the projectile with the free fall. Free fall is the motion, projectile is the object. So that's the difference. Okay. 3.2. Let's calculate the velocity at which the ball A hit the ground. So since ball A was thrown vertically downwards, this is, we can say here is A, then here we can call it B. So this ball is thrown vertically downwards from this height. So it means that initial velocity of this ball is 10 meters per second. Then the height of the ball is 13 meters. So that, in other words, we are looking for the final velocity. So we can have the formula sheet. Let's say this is the formula sheet now. So since we are looking for the final velocity here, it means that we have the initial velocity, we must have the initial velocity, we must have the height, we must also have the acceleration, which is 9.8 meters per second squared due to gravity, always downwards. So it means that we can use this formula because we are looking for the final velocity. We have the initial velocity, we have the acceleration, we also have the distance. So it means that we're going to say Vf squared is equals to Vi squared plus 2a change, since this is the vertical projectile, vertical y. Be careful. Okay. So now we're looking for the final velocity. The initial velocity is what? This is 10 meters per second. But before we do that, we must choose the direction. Let's say here we choose down as positive. So since we are choosing down as positive, the velocity is going down. So we're going to have 10 squared plus 2. Since it's down as positive, our gravity, our acceleration is always downwards. So this one's going to be positive 9.8, and then the distance is 13. So here we can just punch the calculator and find the answer here, which is going to be 354.8. So don't forget this side is Vf squared. So since we're looking for Vf, not Vf squared, it means that we must take the square root of both sides. So Vf is equals to, this one's going to give us 18,54 meters per second. So since the question said velocity is a vector, that means we must also show the direction. So we chose down as positive and check the answer is positive. It means that the velocity is going where? Downwards. Downwards. Right. So, this one is 3.2.1, right? So 3.2.2, we calculate the magnitude of the average net force exerted by the ground on the ball while it is in contact with it. So the force that they're talking about, they said the time of contact with the ground is 0.3 seconds. Now they're looking for the force. It means that we must apply Newton's second law in terms of momentum or the impulse. So Newton's second law in terms of momentum is F net change in time is equals to the change in momentum. So F net change in time is equals to the change in momentum is mass, then it's into final velocity minus the initial velocity. So to simplify life, let's say F net is equals to this mass is what? We are given 200 here, 200 grams. So 200 grams we divide by 1000. So the answer is going to be 0.2, right? So we're going to have 0.2 as the mass. And then the final velocity here is the velocity at which the ball hits the ground. So, the velocity at which the ball hits the ground, now we take it as initial velocity, and then the final velocity is the one that the ball is leaving with. So final velocity, they said the ball left the ground with the velocity of 24 meters per second. So it means that since it's going up, it is in the opposite direction now. So we take the negative 24, then minus initial velocity now is this one, so it's 18,54. So we divide the time, they said is 0.3. So now the answer, we just punch the calculator to simplify life. So the answer is going to be negative 28,56 Newton. But since this is a vector, so it means that we can conclude and say, therefore, F net is equals to 28,56 Newton. So this is just the answer because they said the magnitude. So they're only interested in the magnitude, not the direction. So at the same instant that the ball A is at its maximum height after the first bounce, a similar ball B is projected vertically upwards from a point of 2 meters above the ground with the velocity of 15 meters per second. So now 3.3, let's just do this, divide here. So 3.3, we must calculate the time it takes for ball A and ball B to pass each other. So ball A and ball B met somewhere and pass each other. So we should know the time, or should calculate the time when they pass each other. So since we have two balls here, once you are given two balls, there's only one formula that you are going to use. So this is the only formula that we are going to use. Change in y is equals to V initial change in time plus 1/2 A change in time squared. So this is the only formula that you must use as long as you are dealing with two balls. So now let's take down as positive. So we can say down as positive. Right. So since down is our positive now, this is what we're going to do. We're going to take ball A first. So let's say ball A, we're taking ball A for now. So this is our formula. Change in y is equals to VI, the change in time, plus 1/2 A, the change in time squared. So the distance where they're going to meet, we don't know, right? So let's just take it at that one. Is equals to the initial velocity of ball A. They're talking about when ball A was at the maximum height. So ball A at the maximum height, the velocity was 0 before it come back down, right? So that's when they decided to release ball B, or to throw ball B upwards. So when they release ball B, when they throw ball B up, ball A was at its maximum height, so the velocity was 0. So we're going to take that one as initial velocity 0, and then the change in time plus 1/2. Since we took down as positive 9.8, and then the change in time squared. We don't know the time, right? We're looking for time. So here, this 0 times time is going to give us 0 plus, let's say this one 1/2, simplify life, 9.8. Change in time squared. So let's say this one is equation 1. And then now for ball B, we're using the same formula. So this is the change in y, VI, the change in time, plus 1/2 A, change in time squared. So now for ball B, since ball B, it was somewhere, it was 2 meters above the ground, but since ball A, they said it was 30 meters above the ground after the first bounce, it means that now the distance between ball A and ball B is what? Is 28, because ball A is 30 meters above the ground after the first bounce. But ball B, it was 2 meters above the ground. So 30 minus 2, that is 28 meters. It means that ball B, it was 28 meters away or apart from ball A. This is ball B we're talking about. So now let's say we take the distance where they're going to meet, since we don't know, and then we subtract 28 meters. That's where ball B was. And then the initial velocity of ball B, it was what? It was 15. Change in time plus 1/2, 9.8, the change in time squared. But let's check something else. 15, since ball 8 was going up and we chose down as positive, so it means that this 15 is going to be negative now. Makes sense. So let's say now we let this one subject of the formula. The change in y is equals to negative 15 change in time squared plus 1/2, 9.8, the change in time squared, and then we take 28 to the other side, it will become positive 28. Right. So now let's equate the equations. Let's say now equation 1 is equal to equation 2. So now what is equation 1? Equation 1, let's ignore the 0. So it's 1/2, 9.8, change in time squared is equals to equation 2. This is equation 2. So it's going to be, oh, this one's not squared, sorry. It's not squared. So it's negative 15 change in time plus 1/2, 9.8, change in time squared, then plus 28. So Now, when you take this to the other side, when you take this one, let me do this. When you take this part to the other side, it will become negative, right? So, since it becomes negative, it means that now we're going to have this part minus that part. Okay, let me have another marker. So, we're going to have this part minus that part. So, they're going to give us 0. So, let's simplify life now. So, it means that now we're going to take 28 back to its original position now. So, we're going to have negative 15 changing t is equals to, when you take 28 to the other side, it becomes negative 28. So, now we divide by negative 15, divide by negative 15. So, now the change in time is going to be 1,87 seconds. So it means that now this is the time where ball A and ball B, or when ball A and ball B met, right? So now let's check the last question. The last question said draw a velocity time graph for ball A from the moment it is projected down until it reaches the maximum height after the first bounce. So we can open the new page. Here now we must draw the velocity time graph for ball A, only ball A. So this is what we're going to do. I will draw both of them so that no one will be confused. So I will take up as positive and then I take down as positive. So let's say the first one we take up as positive. This is 3.4. We take up as positive. So now, since we took up as positive, this is our graph. So remember, here is velocity. And then here is time in seconds. This one is in meters per second. So now, since we took up as positive, now that means this is ball A, up is positive, right? So this is ball A going up, 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 up. Oh, sorry, it's going down, sorry. Since it was projected vertical downwards. So this is ball A going down, 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 down. And then here is a ground. So now, this is the bounce. We show the bounce with the dotted lines. This is the bounce. And then, so since this is the bounce now, this is ball A now leaving the ground, and then it reached the maximum height. So the maximum, at the maximum height, the velocity is 0, right? So here is the maximum height because velocity is 0 here. So this is up as positive. But for down as positive, I will use another color. So for down as positive, it's just vice versa. So for down as positive, let's do this. Oh yes. So still this is velocity, meters per second, and then this is time in seconds. So since down is positive is the opposite of this one, it means that now we're going to start here. So remember, we don't start here because the ball, it was not dropped, it was projected downwards. So we only start here if the ball, it was dropped. So the ball, the initial velocity of the ball was not 0. So this is the ball now going down, 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 and then it hit the ground here. So now we show the bounce. This is the bounce. And then now this is the ball leaving the ground now, and then it reached the maximum height. So it's the same as this one, but just because it's vice versa now. So we can say up is down or down is up. So since we chose up as positive, we started down. But we chose down as positive, we started up. So we can claim this way up is down or down is up. So this is the graph for the down is positive. This is the graph for up as positive.